All right, this is Algebra 1, Chapter 6, Section 5, Graphing Linear Inequalities in Two Variables. You are going to be able to graph a linear inequality on a coordinate plane. So let's look at some vocabulary. A linear inequality. It's not something you've done before. We've solved them but not graphed them. So a linear inequality is a linear equation. So it's in slope-intercept form, but instead of an equal sign, we can have less than, greater than, less than or equal to, or greater than or equal to. The solution of a linear inequality is going to be the coordinate, or the set of points that makes the linear inequality true. The set of points that makes it true. The graph of the linear inequality is going to be on a coordinate plane. I know previously you have used a number line with an open circle and a closed circle. Now we are using a coordinate plane, and instead of an open circle, you're going to be graphing a dashed line. And instead of a closed circle, you'll be graphing a solid line. And then a half plane. You are going to be dividing your coordinate plane into two parts when you put your line on it. So the half plane is just the two sides of the line. It's separated into two half planes. Let's take a look at example 1. Let's first just check whether an ordered pair is a solution of an inequality. So we have our inequality 8x minus 4y is less than or is greater than or equal to 3. So our first point that we're going to use is 0, 0. So let's plug 0, 0 into the inequality. So then we have 8 times 0 minus 4 times 0 is greater than or equal to 3. Simplify. So we are left with 0 is greater than or equal to 3. That is false. So 0, 0 is not a solution to this linear inequality. Let's try 1, negative 1. If we plug 1, negative 1 into the linear inequality, then we get 8 times 1 minus 4 times negative 1 is greater than or equal to 3. When we simplify that all the way, we're left with 12 is greater than or equal to 3. That is true. 12 is greater than or equal to 3, so that means 1, negative 1 is a solution to this linear inequality. And if you take a look, no, never mind. Let's move on. Okay. These are the rules for graphing a linear inequality, or the steps, not necessarily the rules. Step 1 would be to graph the corresponding equation. We are going to use a dashed line for inequalities that are greater than or less than. Remember, I mentioned the dashed line is similar to an open circle. And you know when you're graphing on a number line, that open circle means that value is not a solution of the inequality. The same applies to the dashed line. The dashed line, all those values are not solutions that fall on that line, just like the open circle. Then we would use a solid line for inequalities that are greater than or equal to or less than or equal to. We are going to use a solid line, and that solid line is similar to that closed circle. And we know on a number line that closed circle means that that value is a solution to the inequality. The same goes for the coordinate plane. The solid line means that all those values that fall on the solid line are solutions of the inequality. Step 2 would be to actually draw your line. From step 1, draw the line, and you will be separating your graph into two half planes. It won't be directly in half, but it will be called a half plane. Then you are going to use a test point, which you will see in our next example. You are going to use this test point to determine which half plane contains all the solutions of the inequality. And step 3, once you determine which side of the line contains the solutions, you are going to shade that side. So for example 2, we are going to sketch the graph of x, get rid of that for you, x is greater than 3. So it says to graph the corresponding equation x equals 3. And we know that x equals 3 is vertical. But me personally, I would forget that I turned my greater than sign into an equal sign, and then I would forget altogether that I'm graphing an inequality. So I like to imagine inside my brain that it's an equal sign so that I know it's a vertical line, but I don't actually like to change it on my paper because then I will forget. So in my head, I am seeing this as x equals 3, and I know x equals 3 would give me a vertical line. But really, it's x is greater than 3, and I know the greater than symbol would give me a dashed line also. So I am graphing a vertical and dashed line. Now when you're graphing on here, this is already done for you, I know, but I'm going to graph right over it. I usually will draw a nice solid line, and then I'm just going to go back and take my tiny eraser and draw my dashes. Orange on red wasn't the best choice, but you get the idea. So there's my dashed line. Now for the test point. The test point is any point on this coordinate plane. Any point on the coordinate plane that is not on this vertical line that you just graphed. So it can be any point anywhere except this vertical line. Typically, if possible, you are going to use the origin, 0, 0. That is the easiest point to use as your test point. It's right in the middle, it's zeros. Who doesn't want to multiply by 0? In the event your line would go through the origin, you would have to pick a different point, but you can always use 1, 1, or 0, 1, or something else that is equally as small. So we are going to take our test point, 0, 0, and it is going to tell us which side of this line we're going to shade. It's going to tell us which half plane to shade. So if you come right down here, test point, we have our original equation, x is greater than 3. Our test point is 0, 0. So we are going to take the x value of that coordinate and plug it into our equation. 0 is greater than 3. This statement is false. So that means the half plane that contains our test point, which is right here, is not a solution. This entire side of the line now does not contain any solutions. So you have to shade the opposite side. If it's false, you shade the opposite side. So we are going to shade over here. The right side of the line contains all of the solutions. So if the test point is false, you shade the side that does not contain the test point. If this test point was true, you would shade the side that did contain the test point, but it is false. And the solution is all values greater than 3. All the values. Let's come down here and do some checkpoint problems. The original checkpoints are already done for you, so I gave you 2 new ones to try on your own. Try out that test point. Pause. Come back when you're finished. Here are your answers. So the first one, x is greater than or equal to 4. In your head, you know this is x is equal to 4, and this is a vertical line. The greater than or equal to sign tells us it's going to be solid. So we graph that vertical solid line on x equals 4, and then you're going to plug in that test point. I plugged in 0, 0. So I plugged in that x value of 0. 0 is not greater than or equal to 4, so that is false. So my test point is right here. This whole side is now false, so I am going to shade the opposite side. All of my solutions now fall on the right side of the line. Number 2, y is less than 5. Y is equal to 5. I know y is equal to 5 would give me a horizontal line, so I'm going to plot the value 5 on the y-axis, and then I'm going to draw a dashed horizontal line. My test point 0, 0 would be 0 is less than 5, which is true. 0, 0 is right here, right in the middle. It is true, so that means this entire side of the line contains all the solutions of this inequality. Now let's graph this linear inequality in slope-intercept form. We are given the inequality 2x plus 3y is less than 6. So we know right off the bat this is dashed. Oops. This is a dashed line. We also know right off the bat that this is not in slope-intercept form, and I can't graph this. So in order to graph it, we need to turn it into slope-intercept form. And with the magic of technology, here you go. It is already in slope-intercept form. So we are going to graph this equation, this inequality, in slope-intercept form. First, by graphing the y-intercept, 2. Then we are going to go down 2 and over 3. I can't go down and to the right anymore, so I'm going to try going up and to the left. Remember, you always want to make as many points as possible so that you can have a nice straight line. Now, luckily, this is already drawn for me. So I don't have to make a whole lot of effort being straight line, but there we go. There is my dashed line that represents the linear inequality y is less than negative 2/3 x plus 2. Now for the test point. There is a whole explanation over here already for you about the test point. Remember, the test point is any coordinate that is not on the line. So right now, 0, 0 right here is definitely not on the line. So we are just going to use the coordinate 0, 0. My test point is going to be 0, 0. So this is my x, this is my y. I am going to plug them both into the equation, the inequality. 0 is less than negative 2/3 times 0 plus 2. 0 is less than 2. Is 0 less than 2? It is. This is true. That's not how you spell true. This is true. That means you are going to shade everything that contains 0. You are going to shade the entire side that contains the 0. So you are shading everything down this way, this whole side. And there we go. Here you have some checkpoint problems. Just make sure that you are able to turn these into slope-intercept form and graph in slope-intercept form. So pause and come back when you're finished. All right, here are your solutions. Now, I know that you are probably able to do number 3 with no problems. You found out that the test point was true and you were able to shade. Now for number 4, something I want to point out. You had to divide by a -1. Your rules of linear